Hi everyone, this is JJ, and today I'm going to be talking about finally out of development released experimental render graph API in Unity version 6.3, and it comes with a whole lots of changes to how developers can easily write their own custom render features without having to worry about synchronization and resource management. Some goals. The first thing that we're going to do is create a simple full screen effect. After, we're going to be creating a BlitBlendPass for some artistic blending. Then we are going to be adding a selective target render pass. And then lastly, we're going to be creating an AfterImagePass using the CameraHistoryItem and the HistoryManager on the camera. I would highly recommend watching render graphs and high-level rendering and modern graphics APIs, as well as the introduction to render graph in Unity 6 we will be covering most of in the first part of this video. I would highly give Introduction to URP for Advanced Creators a read if you are interested more in the shaders and technique side of it, as well as the other new features in Unity 6. So the first thing that we want to do is create a custom full screen shader that we're going to be using. So we can do that easily by using the shader graph. So if you import the shader graph package, you have access to creating a full screen shader graph right here. And so we're just going to call it our custom full screen, or just custom full screen. Why not? We can fully open this out. So the way we can grab the full screen buffer is by going here and typing URP sample buffer. And instead of the normal world, we're going to come here and we're going to click our Blit source. So it's pretty simple. And I think the first thing that I want to do is I basically just want to desaturate the color. That way it's pretty obvious. So we'll go here, we'll go to color space conversion, convert that to an HSV. We'll split this up. We'll make this into a vector 3 and pass it into the Z and zero out everything else. And then color space that back as well from HSV to RGB. Beautiful. The next thing that I want to do for some added visuals, I guess, is we're going to have a UV halftone. And what we're going to do is we are going to increase our dot density, set our blur min-max to 0.5, 0.5, zero out the rest of the stuff. We don't really need to pan nor rotate, but I do want to get the width and the height. Turn this into a vector 2 and plug that into the container ratio. So we do that. And lastly, we just multiply these two by the color and by the dot halftone. And then we'll output that in the base color. So we have our simple shader here, and we'll save that. And then what we will do is create a full screen renderer feature. And we're creating our first custom full screen renderer feature and we're inheriting from the scriptable renderer feature class, as well as you will need a scriptable render pass, and we're going to call it full screen render pass. Okay. An instance of it, so we're declaring it there. And then when we override the create method, we need to create our render pass. When we add our render passes, we're enqueuing the pass to the renderer via renderer.enqueuePass. Here's our settings struct. So all it is just a container that contains where we're injecting it. So it's a render pass event and the material that we're using. And we're just going to declare it right there. And we're going to serialize the field so that we can expose it in the editor as well. Inside the full screen render pass, pertaining a copy to the read-only settings, and we're passing it via the constructor, and we're again setting the render pass event there. And here's the new API, the override void record render graph method that takes in the render graph that we're currently using, as well as the frame data or the context container for this frame. So we contain the name of the pass name via the nameOf function. And then these are the resources that we're going to get. We're going to get the universal resource data as well as the universal camera data. If our camera type is equal to the preview camera, which is the like little inspector preview thing, we're going to return. We don't want to apply our effect there. If you do, you can just ignore it and don't call this function. This logic right here. As well as if our current resource data, if we're targeting the back buffer, which means we're not actively targeting the active color or the thing that's going to draw to the screen, then we can throw an error and say, hey, we're writing to the back buffer or to a buffer that's not our main buffer. We then create a new texture, which is going to be our destination texture, and we're using the active color texture from resource data. That is like the description of the actual texture that we're writing to or to the camera, and we're giving it the name of Fullscreen render pass texture. And rendergraph utils.blit material parameters is a helper function that Unity provides easily for us. So we can just pass in the active color texture, which is going to be our source, our destination texture, the material that we're going to write, and the pass index. And then finally, we're just setting the camera color to our destination texture, and that's pretty simple. So now that we created our custom full screen render feature script, we want to assign it to our settings. So if we go into our asset settings back here and we click add render feature, we have access to the custom full screen render feature. Obviously, when we add it, it's going to give us a warning because we don't have the material assigned. So we're just going to click here and we're going to click on our custom full screen shader graph material. The next thing that you may want to mess with is the render pass event, and this is actually the injection point of when this pass needs to render. So if we do usually after rendering post-processing, so this is all the way after the end, after the post-processing, it applies to everything in the scene, including any full screen image effects that you have previously. When we do apply it, if we go here into our analysis and we go back to our render graph viewer, we should see that our custom full screen render pass is injected right there. Okay, so here's our pass, and it basically reads the camera color after post-processing texture, and then it writes to this custom full screen render pass texture that we created and are using. Okay, so we can add it there, or if we want to change it, let's say we want to do it so that it renders before transparent objects, we can. So if we take a look over here and try to find it, it's right here. So it's rendering before we render transparent objects. And again, same thing. And we can actually visually see this if we add a sprite. So if we go to here and let's add a square, right? And we move the square right in front. The square isn't affected by the full screen render feature, but everything else is, right? But again, it's because of where it's being injected. So if I mess with this again, and let's say we want to render this after rendering our opaques, then only our opaque objects get rendered. Unity also already provides this feature. If we come here and we create a full screen pass render feature, we can actually, let's just disable that. And if we add our custom full screen material, we get the same effect, except that this has a more limited injection points. So yeah, it's pretty similar. Ours is a little bit more powerful, and we're going to be adding more to it too. So let's add a BlitBlendPass to our render feature. The first thing that we're going to need is a custom blend mode enum. And I had to do this because I couldn't expose Unity's default blend modes, as well as if you want to add your own different blend modes, you can as well. You can extend this. But yeah, the shader. So we are passing the enum via the enum property. and it will be a type of integer. And then we're also passing in the blend amount. The only important thing here about the subshader is the tags, especially setting the render pipeline to the universal pipeline. And then, we name our program, we begin the HLSL program, and two important includes that we need to include is the common universal shader library core.hlsl and the blit from the runtime utilities from the SRP core pipeline. And yeah, this will have functionality. The blit.hlsl will include the vertex shader that we're using over here when we call pragma vertex vert, and the fragment shader is the one that we're going to be overriding ourselves. There's other functionality in core.hlsl, especially when it comes to textures. Instead of having to do the texture 2D and then space underscore blend texture, there are functions that Unity provides, whether the texture is a 2D array or just a normal texture 2D, or whatever sort of texture type that needs to be included or used. So this is an automatic way of encompassing all those texture types, and they provide useful macros for us to use. If we are using the full point precision, we do texture underscore x underscore float, and we pass in the blend texture. Otherwise, texture 2D underscore x is half precision. And then we include our properties that we included up there. So float blend will be from 0 to 1, and our blend mode enum index. There are utility functions. I'm not going to explain them. You can take a look at them in the source. But the fragment shader hold a reference to the base color and the blend color. If we are using a texture 2D x as array, so this is another useful macro that Unity provides. So if it is an array, we will do a sample texture 2D array LOD. So again, LODs are also included. The blit text array slice and the blit mip levels are, and the blit texture as well, and the samplers are all included from the core.hlsl, as well as the blit.hlsl includes. So all we need to do is pass in the input.text chord for both the base color and the blend color, and then we get our values from that. So it's really simple. If we are not using a texture 2D array and we're using just a texture 2D normal, then we are using this macro to basically set up for VR if we're doing like multi-pass rendering. This is what I had to do and what I discovered whenever I wanted VR support. Yeah, we do the same thing, sample texture 2D underscore XLOD. We pass in our blit texture, a sampler, the input text chord, and the blit mip level. We do the same thing for the blend color. And then finally, we return the result of the blend function, which passes base color, blend mode, and blend. And it looks like this. We omit the alpha and only get the RGB values for both A and B. And depending on the type that we're doing, we perform an operation, and then we lerp between the blend amount, right? So that is the result. Finally, we lerp the alpha values and return that. Okay, so after we create a new blend blit shader, as well as adding the BlitBlendPass, we need to create a new material because it is throwing us an error. So if we come into here, in our materials folder, we create a new blend blit material. And we're going to base this off of our SRP, blit, and blend. And then we go to our settings, and we come here, and we add our blend blit. Everything should now be fine, and no more errors. And we can actually blend. So let's actually just do add. And we're blending our material now. And so we can do different things. We can multiply. We can divide. Divide. And yeah, we can apply based on the Photoshop sort of style of blending. Oh, pretty nice color burn, but I'm just going to stick to add. Now that we've added blending, let's create selective target rendering. And then what we're going to do is modify our settings class. We are going to add a preview toggle. We are going to add a list of shader tags that we want to use, as well as any override settings for our camera. And we're adding a render queue type, as well as the sorting criteria. And we're using a layer mask and any render layer mask so we can do our filtering, as well as adding an override material so that we can render all of the targets using a custom override material. And then finally, we have two helper functions that basically takes the render queue type enum and converts it back to a render queue range, which is what we're going to need to use, as well as taking the strings of shader tags and converting them to shader tag IDs. Inside our full screen render pass, we need a render pass data, which will just include a handle to all the objects in the scene. And the changes that we're going to make to our record render graph is we're going to need the rendering data, which is what we call it with frame.get universal rendering data, as well as the light data. If our camera type is the preview, we return. If we're drawing to the back buffer, we throw an error. If we are overriding the camera settings, then we want to set it to use our sorting criteria, as well as the otherwise we're just using the default opaque sort flags. And if we want to override the render queue range, we can as well. Otherwise, we're defaulting it to the opaque. Filter, and then we create a new filter settings, okay? Or filtering settings, which we pass in our render queue range, the layer mask, as well as the settings layer mask. Unity provides a helpful rendering utils class, and this is how we create our drawing settings. We pass in our shader tag IDs, our rendering data, our camera data, our light data, and our sort flags, as well as inside the drawing settings themselves. If we do have an override material, then we're setting it. Otherwise, we're not. And then finally, we create a new render list params, and we pass in our color results of the rendering data, our drawings, our draw settings, and our filter settings. Okay. Before we created our destination textures using render graph.create texture, and we pass in our active color texture. But the only issue is there was like this third optional option where you can actually pass in whether it wants to be cleared. But the unfortunate thing is it doesn't actually apply a clear color. So we don't want to do that. And instead, we want to get the description of our texture, give it a name, clear the buffer, and then we want to set the clear color as well. And then we finally create the texture passing the description here. And so this is, we want to do this instead. And yeah, so we add a raster render pass as we did before. We want to pass in the actual pointer by telling saying, hey, render graph, here's a whole bunch of items. Can you create a render list for me? And it does that for us. And then we want to say, hey, we want to use this render list. So we set our render attachment like we did before and our destination texture, and we're saying, hey, we're writing to it. Here we are just basically taking our render list and just drawing it via the context.command.draw render list. So we do that, and that's it. It's pretty simple. Okay, after that, if we are previewing the destination, we assign camera color to the destination texture. Otherwise, we are doing the same thing as before. We create a new destination texture. We're applying our custom full screen render feature. And then we do the blending as well. And then we assign that blend destination texture to the camera color. Okay, so coming back to Unity, we're going to remove our custom full screen render feature, and we're going to add our custom full screen with target render feature instead. We're going to get more errors as well, And so what we want to do is, the first thing that we're going to do is assign a blend material, and that's going to be our blend blit, and then our custom full screen material. So we're almost back to normal if I add, and if we do after rendering post-processing. Okay. So yeah, we should be back. Everything is exactly the same. So what we want to do, if we want to test this out and say, let's say, I think to the spheres, I've added them to a layer called target renderables, and you can add layers by going here and like assigning your own layers, as well as there are things called rendering layers, which you can add here as well. So layer 8, layer 9, you can add as many rendering layers as you want, I think. Or there's like a limit, 256 or maybe 32. I'm not too sure. But apart from layers, you can do rendering layers. So if we go back to our settings, and let's say our rendering layer mask is nothing, but then we want to apply to our target renderables, and let's enable our preview. So the only thing that is being rendered currently now is just our target renderables. So everything there. So if we disable our preview, obviously the custom full screen shader is being applied only to these things. And additionally, if I think one of these spheres, if we go here and go to the mesh renderer, and you can actually assign the rendering layer mask here. So if you can set it to nothing and then set it to layer 8 and possibly default. So we can go back here, and instead of everything, we just want to render layer 8. So here's that sphere. And so it's only applying it to this object. So if we go to preview, obviously there it is. And yeah, it's really that simple, honestly. And there's a lot more powerful features. We can do things like maybe even changing the override material. So if we come over here, let's enable our preview. Instead, let's assign it a normal material that we have. And yeah, we've overridden it. Very powerful stuff. And yeah, that's target rendering. Let's finally create an after image render feature then. So we're going to inherit from the scriptable render feature class again. Inside this class, we're creating a new after image history, which is a camera history item. And this allows us to basically create a render texture externally and allows us to save to that texture. Each of the items need an ID and a hash, and we are also giving it a name, and we're giving a simple one, just taking the name of the class. We need actually two render texture handles, so the current texture and the previous texture, so the current texture this frame and the previous texture last frame, and the camera history item provides these two functions in order to get them. In order to import the texture, we just call rendergraph.importTexture, and we pass in the current texture, and then the import previous texture. If our previous texture does not equal null, then we import that. Otherwise, we just return a null texture handle. In our onCreate function, we call base.onCreate, creating a new ID, and we're passing 0. We're only having to create one of these after image history items, so we don't need many of them. And so we just pass in 0. Reset just releases the history frame, and we pass an ID, so it will release both the render textures. In our update, if our texture descriptor, so if any of the sizes or any of the settings inside this descriptor changes, and our hash isn't the same, then we want to release the texture frame. And if the current texture is null, which obviously it will be, then we want to allocate the two render textures. So we pass in the ID. We actually pass in 2 here because we're allocating 2 textures. We pass in the descriptor and the name of the texture, as well as we are recalculating the hash, right? And yeah, and that's that. So we're taking our settings class from before, and the only thing we're doing is we're getting rid of the material. We're adding the same blend section, And the new section that we're adding is a lerp section. So this takes in our lerp material and our float lerp. And the rest of the settings are the same. Okay. And we're still exposing the reference there and doing all of the same stuff using in the AfterImagePass. Then in our AfterImagePass, it's going to look the same as before. We have our settings. We are passing our settings here. We have our RenderPass event, so we're hooking it up. And then we have that, and yeah, and the only major thing is the record render graph. So let's take a look. Our record render graph function looks exactly the same. We're doing the same things as before, including the raster, the target raster render pass. But then after, we have a new extension function for the universal camera data. So this is the camera data.tryGet function. We're trying to get the after image history. And it looks something like this. If our history, if the history manager does not exist, we return false. We request access to it, and then we also tell the history manager, hey, we want to get the history for write since we're writing to it. Lastly, if the history object does not equal null, then perfect, then we got the history, everything's working. So going back to that function, right? So if our camera data fail or the try get history fails, we just return. Otherwise, we get the descriptor of the camera. We set the depth buffer bits to 0 since we don't really care about the depth buffer, and we pass that into the history update function as before. Then we import the current texture and previous texture, and then we do everything as before, except that we're adding a BlitBlendPass, and we're passing the target render dust texture, the history texture read, the settings.lerp material, and the lerp itself. And almost exactly as the BlitBlendPass, we're doing exactly the same, except we are setting the materials float lerp property and lerp texture instead. And then another overload of that function that returns back the actual destination texture. So that's what we're doing here. We're getting the lerp destination texture. If we can copy that destination texture to the history texture right, then we do so. And then finally we blend between the active color texture and the lerp destination texture via our BlitBlendPass, and assign the blend destination texture back to the camera color. Okay, so now that we have our after image render feature, we need to create our BlitLerp shader. We are going to create another shader graph shader. So we're just going to go over here. We are going to go to shader graph, URP, full screen shader graph, and we're going to call this BlitLerp. And let's take a look at that. So we are going to need actually some parameters. So the first thing that we're going to need is a texture 2D, and this will be our lerp texture. And then we're going to add a float parameter called lerp. So we need our URP sample buffer, and we're going to get our blit source again. And from our lerp texture, we're actually going to sample that texture as well. We want a lerp, and we're just going to do a simple lerp. So if we come over here and we type in lerp A, lerp B, and then the float lerp, and pass that into our base color, and that's it. And we can save that. And let's go back to our settings. So in our settings, we're going to disable our custom full screen with target renderer feature and add our after image renderer feature. We need to assign our blend material. So that's going to be our blit, and then we're going to add our BlendLerp material as well. We are going to change our RenderPass event to after rendering post-processing. And let us increase our lerp value. We should get it to somewhere good. And also, let's add a little bit of blending. So if we see that, and now we have our wonderful after image effect. So yeah, it's pretty cool. And we can set our blend mode as well to, let's say, something like screen. Let's set that to 1. And let's set our alert value to a good number like 0.98. So yeah, so it's pretty simple. We have our wonderful thing. And again, we have all of the same thing as the target render feature. So if we want to only apply it to the spheres, we can, right? And yeah, and if we also want to override the material, we can set it to normal, and we have our normal material instead being rendered. So it's pretty cool stuff. So yeah, so where do we go from here? While the world is your oyster, you can definitely abstract the target render feature and render it wherever you want in wherever injection point you want. So render that first and then pass it later to a different pass. Shaders, compute shaders, see what you can do with it, create your own awesome effects. And yeah, that's it. Thank you so much for watching, and I hope you enjoy. If you like it, give it a like, perhaps subscribe if you want to. Otherwise, I will see you in the next one. Toodaloo.